All right, so today we're going to be solving the integral from 0 to 1 of the natural log of 1 plus x squared, and so on, all divided by x with respect to x. And so the first thing to really dig into here is this infinite series inside the natural log. So we know we can write this out as the sum from n equals 0 to infinity of x to the n. And the thing to notice about this is that we also have the series from n equals 0 to infinity of x to the n is equal to 1 over 1 minus x for all values of x less than 1. So, since our bounds are between 0 and 1, we can just use this for our infinite series here. So we can say that 1 plus x squared, so on, is equal to 1 over 1 minus x. And that's because we're inside the bounds between 0 and 1, right? So now I'm going to rewrite this. We have I is equal to the integral from 0 to 1 of the natural log of 1 over 1 minus x, all divided by x with respect to x. And we can actually just rewrite this integral as I is equal to the integral from 0 to 1. We can use the rules of logarithms to flip around that fraction inside, and we get negative natural log of 1 minus x all over x with respect to x. Okay. So the next thing is we have an infinite series for the natural log of 1 minus x. And that is the series from n equals 1 to infinity, negative n equals 1 to infinity of x to the n over n. And then obviously if we move that negative sign over, we get negative natural log of 1 minus x. Or why am I rewriting this? I can just negative natural log of 1 minus x. Get rid of that. Okay. And then if we divide out by x, we get negative natural log of 1 minus x all over x is equal to the sum from n equals 1 to infinity of x to the n minus 1 all over n. And so we can go rewrite that into our integral. So we get I is equal to the integral from 0 to 1 of the sum x to the n minus 1 all over n dx. We can pull that sum out and the 1 over n out, so we get n equals 1 to infinity, 1 over n times the integral from 0 to 1 of x to the n minus 1 dx, which we then get the sum from n equals 1 to infinity of 1 over n times 1 over n x to the n from 0 to 1. And then plugging in 1 to x to the n, that always gives us 1. Plugging in 0, that gives us 0. So we just get 1 over n. So we can say this is equal to the sum from n equals 1 to infinity of 1 over n squared. And we obviously know that this is equal to pi squared over 6. It's a Basel problem, zeta of 2. take the integral 0 to 1 of the natural log of 1 plus x squared plus x with respect to x is equal to pi squared over 6. And that is the answer for that problem. Thank you for watching.